Just got out the back of a cop car. I haven't been in one of these since I was like 15. This time I didn't do anything. I just got slammed into by a minivan. These fine gentlemen were just taking me home. I was stationary. Somebody was on their phone texting and ran into the back of me at like 40 miles per hour. Naturally, I'm curious about the type of forces that my body was just subjected to. So let's go ahead and calculate those. First thing we're going to do is calculate the momentum of the minivan. The average minivan is about 4,500 pounds. This is about 2,000 kilograms. And the velocity, the lady said that she was going somewhere between 30 and 40, so we'll just call it 35. But instead of 35 miles per hour, we're going to use the metric system because I'm a physicist. This is what we do. And that's about 15.6 meters per second. 2,000 times 15.6 equals 31,000 kilogram meters per second of momentum for the minivan. When the crash happened, that momentum, 31,000, needs to go down to zero. This change in momentum is called the impulse. We already calculated the momentum. This should be equal to the net force times the amount of time. I don't know how long the crash lasts. Let's say it lasted half a second. We divide this momentum, 31,000 kilogram meters per second, by 0.5 seconds, and you end up with a net force of about 62,000 newtons. For reference, this would be like the weight of 6 sedans stacked on top of me. Instead of forces, we could also think about this in terms of energy. We'll start with kinetic energy, which is represented as 1/2 mv squared, m being the mass and v being the velocity. We already know these, so 1/2 times 2,000 kilograms, the minivan, times 15.6 squared, about 250,000 joules of energy, about the same amount of energy that would be delivered in the explosion from a standard stick of dynamite. Why am I still here? Why am I not destroyed? Of course, all of this didn't go into my body. My car absorbed some of it by crumpling. There was heat, sound was emitted. Cars are literally designed to be able to deal with explosive amounts of energy. Many years ago, people thought that the safest car that you could make would have an extremely strong steel frame that didn't give way. Intuitively, you may think that makes sense. Let's put this sort of indestructible shield around the people that are driving the car. But in reality, it's actually the opposite of safe, because if the frame doesn't bend, your body ends up absorbing more of the energy. Modern cars are built with crumple zones in the front and in the back. You sacrifice the car, but you save the passengers. So while my car took a beating, I walked away because modern engineering and some simple physics turned what could have been an explosive ordeal into something survivable.